Welcome back to Ox Tools. I'm Tom. So we're here at Lawrence Berkeley Lab Magnet Development Program, Building 58. You can look it up on satellite and check it out. This is the Magnet Development Program's support shop, and we have a machine shop and then testing facilities for magnets and quite a few other things. An accelerator hall, all kinds of interesting scientific equipment here. But what we're going to look at today is a magnet. It's a 6-layer Canted Cosine Theta magnet that's been wound with a special high-temperature superconducting cable called cork, C-O-R-C, cork cable. And in the last video, part 1, I made this trepanning tool to go inside the magnet bore and clean out some errant epoxy that ended up in the bore of the magnet. So let's go out in the shop and go over to the work stand where this magnet's set up, and we'll check it out. Alright, sorry for the handheld, but it's kind of a tight workspace here. Here's the magnet on its work stand here. You can see how long it is. That's the top flange that supports it while it's in the cryostat, and all the cryogenic and DC power connections at the top there, those big flags. Anyway, that gray structure is an iron yoke that's around the body of the magnet. And then here's the various layers of the magnet, and you can see that canted cosine construction there. So each one of those is a layer with alternating angles that nest together. That's just a wiring diagram there, how they're interconnected. And you can see some of the details here. Instrumentation. And those are the current flag, or the vapor-cooled leads there, and that's where the DC power comes in. And all the way down, and then here's where we're working, down here, down at the bottom. So let's see, I have to somehow get a better shot there. But while we're working on it, they're actually monitoring stresses in the magnet. The magnet is equipped with strain gauges, and we're monitoring any kind of excessive strain or stress on the magnet while we're cutting this epoxy out. So this is the original tool that I made, and you can see they're similar in construction. Now this one I just cut small notches, and I actually silver brazed carbide inserts or carbide chips in there to do the cutting. But it turns out that this is actually hard to sharpen. It's hard to get up into the diamond grinder to touch those up, and also the diameter is considerably smaller. So, and they asked for the length to be shorter too, to make it easier to get into the magnet. Now, here's some of the epoxy that they pulled out of there already. And you can kind of see, pull a couple of chunks out here. So you can see what the trepanning tool's doing there is it's cutting that epoxy, and then it allows them to kind of break it loose from the inside. But you can see, look at that, that's a conchoidal fracture there, kind of like obsidian almost. This stuff is really, you can hear it, it's pretty hard. And then they got super lucky, and this chunk came out. So it popped loose from one end, but you can see how it's thicker and it tapers off. Now what's left in the bore is a thin layer that they're having a hard time getting out with this particular tool. So that's why this one was created. But I'm going to try to drop down and show you the work area down there, down below where they're working. So here we're down at the one end of the magnet here, and you can see the some of the structure of the magnet here. This is where some of the instrumentation comes out down below. Now that center rod that you see there, they have and there's kind of the aperture of the magnet that we're going into. Right now they have one of those ball hones up in there, and I think they were trying that out to see if that would abrade out the that epoxy. So we're going to try the trepanning tool today or tomorrow, something like that. But what we're doing, you see we got a lab jack there, and there's a bearing. So that's kind of a pilot at the bottom. And what we do is we raise the lab jack a little bit at a time as we rotate the trepanning tool by hand. So we've been rotating it by hand, not with a power tool, because we're worried about putting any kind of mechanical stress into the magnet. So anyway, that's kind of what's going on here at the bottom. But let's get up here, and you can see some of the guts of this thing here. This is all signal instrumentation, strain gauges, and there's actually optical fiber here to send signals out and monitor stress and quenches in the magnet. So, and then these are just displacers here. It's not insulation. So this thing is in liquid helium, and ideally we're displacing as much helium as possible because it's expensive, and it's they have a limited quantity typically for a test. Anyway, cool stuff, huh? So they told me yesterday they thought it was a little too tight in the bore. I'm going to check it myself. We're probably going to take a little bit off of the OD. And this is a view down the bore here. You can see my hand down at the bottom. The camera's coming in from the top. And I gotta find a spot where I can get in here. Yeah, okay. And it's a pretty close fit. Let's see, can you see that? Easier from the other side. And when I measured it originally, I used a telescoping gauge, so it's only a 2-point measurement. So okay, so yeah, we're gonna. So the question is how much to take off, right? You can always take more. It's hard to put it back. Yeah, you can see it's touching. Okay. Yeah. So. All right. Well, let's see what we can do here. All right. So the question now is, oops. Which lathe do we use? So we've got a couple of choices here. We can use the 1941 10EE Monarch, or we can use the Hardinge HLVH, or we can use the LeBlanc Regal. I suppose we could use the Turi too, but it's kind of big. Looking at how they're set up, this has got collets on it, so let's use the little Monarch here. Got a 6-jaw on it, and we're gonna have to dial this thing in anyway. I'm just going to dial in this end here. Let's see what we got. Alright, that's a little bit. So this is a buck adjust through chuck here. I always got to remember because it's opposite of a 4-jaw, so that's there's a high, so we loosen our highs to tighten our lows to make that adjustment. Alright, that's within one now. Okay. So I might need a pusher block here, is what I'm thinking. Something like that. Just to keep it from ringing. Okay, let's get ready. Well, after indicating this a bunch, it's not perfectly straight. Seems to be the what's going on. So maybe when I relieve these pockets from this hard bronze, it sprung a little bit. That might be our issue here. Anyway, I still gotta take some off, so it doesn't really matter. I had to relieve the block there a little bit, so hopefully it clears. All right, let's see what our feed rate is. All right, let's take a little off. It's not singing. But we'll still have to relieve the cutting bits a little bit too. So we're just relieving the tool here, and then I already ground the steel back on the belt sander. Let's try that. So I had to do the carbide now. Okay. Okay. Okay, so it's below the body of the cutting edge is below the body of the. Let's check the relief. Yeah, that's well below. Yeah. Okay. Yeah. So we're okay. All right. So they're all clear. They're slightly below the body, the guiding body there. All right. So I think we're ready to give it back to them and let them try it. All right. I'm not. I don't have my little camera tripod here, so let's do a quick pan through my office here, so you guys can kind of see what my office. So I'm looking for a little short tripod, and the best place to look for something like that is in tax area, and hold your breath. Okay, here's tax area. This is what 45 years of service gets you. You can have your work area any way you want it. So if we're lucky, oops, I bumped into something. We might find a tripod in here somewhere. But flashlights, yes. Tripod, no. So over the years, we've had conversations about this work area. Let's just put it that way. So I didn't see a tripod in there. So let's do a handheld. And so I apologize for the shaky handheld. Tripods are so much better. All right. So we're back at the magnet. Actually, let's look at the very top of the magnet because it's kind of interesting up there. And you can see some of the cool fiber optic stuff, signal stuff. These are the flags, lead flags from the different layers, hypertronics connectors, bucket loads of instrumentation, wiring. You can just see how complicated some of this environment is. But let's go down to the bottom here. Hopefully I can, actually I might even be able to look in the camera. Okay, there's our aperture. Can I do this through the camera? Oh. Okay, let me get it in there first. Alright, sorry guys. Looks like it goes in there. Not wiggling too much, so it turns. All right, so I'm gonna turn it over to him again and let him try it. You going the right way? Yeah, you're going the right way. That's pretty good. Does it feel okay?
Yeah. Try to get closer.
Oop. Is it continuing up? Oh yeah, there we go.
See any chips?
Oh yeah. Well, no, it's a great shot on the camera here. So yeah, Are you pushing up?
Yeah. Okay.
Okay. Yeah, I think I see a chip forming on the.
Oh, there's some.
Yeah.
Is it black?
Yeah. No, it looks pretty good. Yeah, it looks like a yeah, it's cutting. There you go. Oh yeah, nice. Yeah. Okay, just don't push up too much at a time. Yeah, just So what you want to do is find idle at a spot there, turn it a few times.
Yeah.
Oh yeah. Oh, this is cool. You can see the chips forming right on the. Look at that! It works.
Surprise, surprise.
Surprise. This is high confidence. What's that?
I think it's best to sit this inside.
I don't know. You're doing pretty good. I mean, this looks excellent on the camera here.
Okay.
Yeah, I mean it's making a nice big fat chip. So yeah.
It's cutting Stycast?
Yeah, it's Stycast. It's gray Stycast. Yeah.
I'm gonna try to see if I can turn because there's a portion with the Stycast.
Yeah, I
don't know
think.
if I can angle it so I can see.
Yeah, no, it's definitely cutting. It's cutting quite nicely.
This
So
is still all bronze. Right?
yeah, cool.
I don't know where it is.
You don't know what?
I don't know which side there's actually a.
Oh, the camera's laying on.
Yeah, it's very confusing. It's like reversing a few times on you before you get to.
Yeah, that's pretty good right there. But you can definitely see it a chip curling there.
Yeah, I can feel the friction. That's when you remove this and then you switch back. This is the noise producing.
Oh, this is low.
So maybe go up by hand a little bit more until you can get it started in that.
We
And
take this out first. And
Okay.
Then put it back, right?
oh, the bearing.
Yeah.
Mm-hmm. Ah, yeah, good idea.
Okay. Yeah. I'm gonna raise this. Right.
Are you approximately on center, you think?
I can't really tell on this
Hard to
side.
tell. Yeah.
The wobble is there's enough
Enough wiggle
wobble.
in the whole
Right.
thing? Yeah, okay.
Which is fine, but it's pretty actually helpful. You know?
Here, let me hold that back.
Actually, higher friction than I expected.
Well, it's take a little bit of pressure to make a cut, right? Is it making a chip?
I feel like this is just a rubber. This doesn't feel like it's. Let me lower it down a bit. Okay, that's too low, so it got stuck there.
Oop.
That's gonna be a little bit.